and happy Tuesday. Happy Tuesday. Okay. Happy Tuesday. Now, where were we? Path to file ID. This might not actually be correct for wall logs. It's correct for assaulted wall logs. Yep. Okay. So if it ends with dash WAL, we know it's a wall log. favors simplicity. I'm just doing it again. There we go. Okay. I didn't get the tea poured. Let's pour some tea. We're not spilling tea. We're pouring some tea. It is chilly out. I have multiple layers on inside the office. Fingerless gloves. But it is gorgeous out. Okay. Examine the contents again. Register the wall log. Okay. If it's salted, read the salt out of the file name, out of the extension, and then we keep moving. Could not parse salt for path. Good. Now, register wall log does not create the wall log anymore, which is fine. Now, if it was not one of the other two, okay. Give me a sec. I have to update my calendar. Okay. All right. Got my stuff scheduled. Hey, let's see. Code. Look at that. There's more code. All right. Where are we going? We got the salt. Whoop. So first, does the wall log end with wall? If so, it's mutable. Otherwise, it's non-mutable. Now, if it's neither of those, what do we do? Skip it? Hmm. I think that's all of them, but I must have been thinking about something else. So those are the ones we care about. This is gone. This and this gone. Yep, that's all gone. And then result is unused. Okay. Mm, why does this return an error? There are no errors. This just works. A couple of hash map rights. We used to create a wall log object in there. Okay, 1, 2. All right. Hmm. Good. Index, fine. And we're out of it. Okay. Start at the top. Application DB dir, wall files. Let's rename that. Wall logs. Let's rename this. This is more of a wall log ID. All right. So remove wall log. Register. Passing an ID in. All right. Yeah, we were just passing an ID in only to create it again. Weird. Okay. So if we already know about the wall log, we return it. Actually, yes. Yes. Okay. Because the file is already created. If the wall log does not exist, we look for a rotated one and get the path for it. The path, let's say, if we didn't have a path, we index. But what do we do here? We don't have a path, we reindex. Then we check for a path again? See, at the end, we should just get the path and open it and store the wall log. Because we don't have it open already. Does this handle the case where remove wall log? Yes, okay. If we do not have it already, index the app db dir. Got it. We're getting the salt one. Because that's what we have here. But what do we do with it? Let's say we get the path here. Great. Then we return the path? No, we have to check that it's a path to that ID. Because basically, we can look up the salt one. And then try to get the ID out of that. If the ID is correct, then we know the path and can open a new wall log and stuff it in there. This is an option. You know, I don't think I want to do this destructuring like this. Or this logic. It's not really destructuring. Okay, so let's just reassign to path if we find something better. We have a possible idea at this point. Now, if they're the same, if the ID is the same as the possible ID, then we set our path. Mismatch types. Ah, yes. There. Handle the some none case as well. Okay. Yes, we will borrow that. Fine. Why is this? Why is this path owned? I guess where would it be borrowed from? I see we clone it here. It's probably for the best. Otherwise we have a lifetime here. That is going to keep us from mutating self in here. Okay. All right. Now that we might have a path, if known path is some, see, we need to, if we do have a path, open it, store it. So there's always the possibility that we don't have the wall log here, that there is no path. We could have just mapped it. So we try to get the wall log. Good. We need to get rid of that. What do we need the file name hash for? Nothing. Perfect. Let's run it. Adjust my headset just a minute. So, where to? We have that kind of running. Let's go to here, give it a read, reload. Okay. Add some data. Oh, nice. So we find the right wall log. It's got one change in it. Let's do it again. Have another commit. Good. Find the file. Changes 2. And our position is good. Nice. Let's go for 3. Beautiful. 3. Okay. Now, let's load this and see if we can force it to a checkpoint. Android. Checkpoint a database. Now I want the SQL. Is this where we just were? SQL. Yeah. Wait, what was this? Pragma. Here we go. Something like so. Okay. Oh, but we have to have the VFS loaded. Can't do that. Do that. Dot load. And where are we? Okay. Target. Was it load? File entry point, yes. Target debug lib reverb VFS. Ah, reverb config file. Okay. App. Let's see. Dev/1/ reverb.toml. Load. No. Okay. We did this out of order. Can't give it the wall log yet. To do that, load it. Open this. Fascinating. Well, it's not a database. Hmm. Because I'm not loading the right thing. Very astute. Okay. Right. Hmm. I don't know if it's actually going to do the right thing because I'm not seeing log messages. Dev/1/reverb log spec trace info. Trace. Oh, and we should change that from the standard error to standard out. Maybe. We'll think about it. Okay. One more time. Connected to a transient in-memory database. Lovely. Okay. Interesting. I didn't realize that that was a default. Oh, load. Okay. Open. Beautiful. Okay. Now that we have that open, oops, do one of these. Lovely. What do we have here? Should wall files be truncated? Hmm. Hmm. Oh, interesting. Okay. Yeah, this definitely needs to get done. Interesting. I'm glad we hit that. So this was size 0 file. There are situations where truncation could not be completed and the wall is truncated. What does that even mean? Okay, let's look up wall truncate. What does this mean? Oh, this is on um, the interface. On these guys. Hmm. I want to know what this means here. Sure, we can truncate a file, but why pass an integer to it? I limit. Interesting. That's a different structure. Hmm. Let's just go look at the source. Oops, wrong button. I just wanted more. OS Win, miscellaneous append VFS. N bytes to a specified size. Interesting. Interesting. If user has configured a chunk size for this file, truncate the file so that it consists of an integer number of chunks. The actual size of the file after the operation may be larger than the requested size. Now, we want to rotate this. We don't want to truncate it. If the file was just truncated to a size smaller than the currently mapped region, reduce the effective mapping. Okay. That's fine. I feel like we have to roll the file and then copy back only so much. In this case, we're truncating to 0. So maybe that's a special case that we could handle. We don't have to copy so much data back. Like in this case, here, we're just at the beginning of the file again. Why couldn't this just be the contents of rotate wall? Because we're swapping. We need to know if we're getting anything back. So we set the salt. Interesting. This. Did we just do nothing? Because if we did nothing, then it would attempt to write at the beginning and then fall into this case. Hmm. Yeah, we don't want this. Let's. Okay, this 136. It's like a little mystery that the previous me set in place. I wonder what that means. If size is less than 136, what's magical about 136 bytes? Fascinating. Okay. I'm going to leave that little love note there for my future self. I've actually truncated. Although, see, I'm concerned about this not getting called. Oh, this here. We could translate it into a write or something. No, we're basically going to close it and open it again, and that should get wiped out. Okay. First write to the front of the file should trigger a rotation. Concern is that whatever this ends up being, it's like we're keeping some for some reason. What does this do? Ah, robust, yes. Is truncating to a specific size. Okay. And retrying on interrupt. Great. Lovely. Mm, let's try that again. Wait, just run failed? What did it fail on? Come on, scroll faster. Broken pipe? Is it closed up here? Oh, it actually did a wall rotation while we were waiting. Okay. Renaming blah to blah. Okay. Segmentation fault. Because yeah, we fiddled around with it in the other one. Hmm. Also, another sort of Roman joke. How did Spartacus feel after a lion ate his wife? Hmm. I don't know. How? He was gladiator. Ooh. That's great. Let's see. Do I need to be concerned about this? What if one of them did a rotation and the other one didn't? Does it matter? Do we have to invalidate our state or at least detect it? I think we might. Hmm. Let's try again. Oh, could not compile. Uh, all right. Here we go. Adding some text. One mutation, two mutations. We'll load this lib reverb bit. Open. What's our truncate? Oh, it panicked. That's right. So it didn't get committed. Hmm. Okay. Now what happened? Here's our wall truncate. We asked for the truncate here. Got a lot of pass through. VFS X axis. Okay. So in theory it's truncated, but not because we didn't try writing to it. And then this one, does it even know? Add a note. We got a mutation here. Is this one okay? It still can select. Fascinating. So truncate just did nothing. That forced truncate. No, in this case. Okay. Let's see if a mutation would end up at the right spot here. Here. Renaming. Okay, so everything except for the hard truncation seems to be okay. Data plane. It couldn't find the previous one. Whoa. That's incorrect. Okay. So that's a problem. The old one. rotated wall path. So in this case, we didn't trim off the previous extension, but I thought the wall path extension. Hmm. Oh, because it was rotated in the other process, this one didn't know about it. So when it did the reindex, it saw that it was salted already, stored the salting. Hmm. Okay, so we need to take that into account to check to see whether or not it's salted. We can just check to see if there's dash wall dash in the name, in the extension, rather. Okay, so we have our wall file here. Okay. That should take care of that. Let's try again. Hmm. Disk IO error. Interesting. Hmm. Oh, data plane doesn't do logging. It does tracing and all that. Okay, let's load that. Let's adjust the logging for it and run it again. Console. Hmm. Trace. That means it happened before. Oh, okay. I think we corrupted a SQLite database. Interrupting. Here we go. Oh, yeah. No, it should be logging to disk, but um, I think it bailed in the section of where we're trying to um, cause the system to do compaction before we even start. Wow. Let's run data archive. That seems okay. All right, find the error. Two range keys there. Interesting. Hmm. I don't know that this is caused by us. If it's just happens to be at about the same time. Let's restart these. Ah, those happen regardless. Hey, Dylan. How are you? Thank you, Museum. So we have a change here. If we load this up, let's try again. Lovely. Could not remove old wall log. No such file or directory. Okay. Because it already happened? Single quotes. Disk IO error. Wall read. Okay. Then we write. File salt not set when processing wall frame header. Interesting. Hmm. Oh, hey, Dylan. Are we building SQLite from source? No. We're actually using whatever's provided. We are creating a VFS, which then gets loaded into SQLite. Yeah, good question. All right. Right to the FIFO, rights that are less than that are not interleaved. Great. And why wouldn't we have a salt? Because we didn't write to the beginning of the file. What happens before that? Can we piggyback off of some read? We just read the file when it gets created. Just one extra read to the beginning of the file in this call. I wonder if it's getting it from the shared memory section. So it knows that it's got 4K page sizes. I'm not sure why it knows that. But again, load anything here? No. We haven't opened the file yet. Open. Of course. This file has everything they need. So if you read, 100 bytes at offset 0, you get it. Okay. Oh, here, these colored messages. Yeah, yeah. That would be enough. Okay, so when we load the file, the wall log, I think we need to check. We need to get that information from the beginning. Either that or the salt is in here. Just switch to where we're getting the salt from. These actually differ in their interface of the salt. This one, I believe, returns a tuple. And, oops, let's go back. No, go back. Redo it. Hmm. And frame header doesn't return a tuple. There we go. In this case, there's, we do not need this. This could be simplified. Good. Okay. Let's run it again. Test. Just checking my audio again. Okay. All right. Give us some data. Hop back over here. We can see, hey, it made it through, found the change. Let's do a second one. Second one, good. Data plane and app one seem to be communicating just fine. Now, I'm going to try to do the same thing here. There's our load. The VFS, open the file, select. Nice. And we wrote something. We received the change here. Good. If we come back and go back to Firefox and make another change with our web server. Oh, look at that. Things are playing nicely together. Same here. I just tried it out of desperation. So, like, oh, please, oh, please, oh, please, control R. Yes! It worked. Okay. There we go. Now, let's try checkpoint. No, that's not it. That's really not it. We want. Let's just try like an easy one. Pragma blah. What happens? Ooh. Kaboom. Segfault. Okay. Hmm. Fascinating. What happened? Pass through. Control. Shimlock. Barrier. All of that. I don't touch any of that. I shared memory bits. Let's see. Does this still. Yep. Got another one. Okay. This is still working. Load. Open. Insert. Where's our pragma? Let's try full. Okay, full. It looks like it did it. Okay. Let's see, did it do it though? Wall sync. Commit page. Checkpoint here. See, it's doing all the shared memory stuff. Then we do a sync on the wall log. We do a read. Where are we going? Why read from the wall log at that offset? Unless we're copying that. Yes, we're copying that 4K back into the main database. Okay. Sync the main database. Now note that we have not attempted to like go back to the beginning yet. So here, does that go to the beginning? It does. Okay. So we insert writing at 0. Okay. Do we not have like some sort of error message? I use error messages just for um, visibility sometimes. Am I using something like RL wrap to add readline support? I don't think so. I installed this with Homebrew. Yes, error for visibility indeed, yes. Um, but it looks like it should have rotated the log. And you use Warn for that? Oh, that's a great, yeah, it's a good differentiator. It's a good idea. I may adopt that if I remember it. You write a lot of infos. There's a noise one. Okay. Yeah. I don't. Hmm. See, here at this point, we should be rotating the wall log. Going to 0. So here, let's do a warn. Okay, and this is an error. Hmm. I didn't see the going to 0 bit. Sync. And if we try to read using that one, okay. The read was fine. Hmm. Okay. Let's try that again. I feel like something was missed here. File header. So we set the salt in the file header if we have the reverb. Oh, but we didn't have that. If we do it again right now before restarting these things, then we should see it. So here, if we do a checkpoint full and then insert, then we see going to 0. Okay. This is because of the salt not having been set initially. So previously, the last fix we did just kick the can down the road a little. Now, the reverb file, it's set salt. We really need that. So whenever we open one of these, we really need to get the salt for it. All right. Maybe we should do a quick read just to get that data. Let's see where we create that. Yes, this is Helix. It is. And welcome, ACEU. Welcome. All right. I love how, like, we're trying to do something and we just get derailed. Now, this is, where does this happen? It happens in VFS file, but not here. Down here somewhere? No, not there. Oh, this is Challenger Deep. Um, yeah. Let's see, where did I find that? Cat Fig Helix Config. So this theme here, I think I downloaded it from somewhere. Oh, there's actually a Helix theme now for it. Okay. This is the main Challenger Deep theme repo. Here, just link this to you. I didn't realize it had Helix in here. That's awesome. Outdated current. Oh no. Well, Maybe it needs people like us helping out. Although I don't think I got it from this location. Um, list of themes. Yeah, here. Oh, I don't see a Challenger Deep here. Oh, these are the built-in themes. Okay. Well, best of luck with that. Now, coming back here. Sorry, I was thinking about other things. Um, could not remove old wall log. Okay, good. But we need to get open file this. Where does this get called? From file? Rotate wall. Okay. That's not the open file I want then. I want VFS. VFS. Here. X open. Here we go. So we call X open further down. That populates the underlying file. So at this point, we could do a read. Okay. Well, after we check the result, see that that's okay. We set our methods. Okay. And then here, here we could read, the first couple bytes of the file, read the salt, and then return that. Is there a better place to get the salt though? We could try to get it out of the shared memory. That of course would require no disk I/O. How's the wall index header? Does it have the salt? Here they are. On the wall file, they're all big Indian. Just like this documentation could be more clear because they define that. Here. Don't they? Hmm. Oh, following 8 big endian 32-bit unsigned integer values. Yeah. But here they specify it's big endian. Why not just specify that it's big endian? At least they specify. Okay, true. Yes, they do specify it. Okay. So we could get it from here, right? That would be just memory mapping the index file, grabbing the salt. We could also intercept the shared memory with a pass through. Because we should be able to see these values getting set. All to avoid a little file IO. Hmm. It's obviously simpler to just avoid the file IO. Because if we have the other pass through monitor for this, hmm, we have to associate those two, the wall file in the VFS and the pass through file in the VFS. We'd have to associate those two. Hmm. Version, I change init. Page size, okay. Checksum of the last frame of the wall. Hmm. I would assume so too, but here, let's come back here. Um, where is it? Here. Right. So in our experiment here, if we look at the actions that are taken by the wall log, we start reading further in the file. We're not actually reading very early. So this could be, half a gig in. And I'm not sure whether or not it would be faster to read the beginning of the file, right, or look it up out of shared memory. I get where you're going though, and I like that idea. I'm just not sure of the kind of system characteristics because that's a big jump. Yeah, like that's it. It's 24 bytes. I know these aren't. We're not using spindles anymore, but I still think about spindles. Right? Like, oh, that's a long seek. Let's do it the right way. Let's do it. Let's just go from the beginning of the file, which we would do here. Now, in this case, we want to use the proxy file. No, not the proxy. We want the underlying file. I wonder when we can call that. So it's supposed to get set here. We look at the results here, and then we ensure that it was set here. Read the second salt pair a bit later in the header. Um, the SHM index file has two. All right. So they have it repeated. I thought, let's see. Oh, maybe not. Here. Now, this would only get set if a page has been written, right? So the second set in the wall log might not actually exist, or it might be for something else. Uh, this is in the shared memory file. No, not the wall log. Stefanoni, we are working on SQLite replication. So we're building a VFS, virtual file system plugin for SQLite. We're using Rust. But musing, I fall into the same trap where this wall index header is, I interpret that as the wall log, and it's not, it's the shared memory. Yeah. I have to run. Dread. Okay. So current plan is to read that data, probably in here somewhere. Something like this. All right. Compiler error, fix me. Good. Okay. But I have to run. So who shall we rate today? Anybody doing Rust? Oh, interesting. Sergeant Pepper doing Rust. We'll rate them. Ariel, thanks for hanging out. And till next time. Bye bye.